Alrighty, I think we're about on our way. Okay, everybody. Just plug my phone in so I can get some charge while I'm waiting. There we go, stick that down there. Yes, hello, new camera. Wait, no, we did this last night. It's not a new camera, who am I kidding? But everything's been cleaned up, rearranged and adjusted. Done quite a bit of changes, all because of that air filter. It's a bit hard to show them all to you with the... I don't have a mobile camera around. I mean, I could have. I've got enough webcams now. But I've also installed a second light. And then I shifted... You remember there used to be 3 bands or 3 light beams on most of the reflections that you would see. Well, I've moved them back behind me, and instead I've got some 30-watt panels above me, so it seems to be doing all right. I suspect there's going to be a bit of an echo in the room for some reason now, but anyway, it is what it is. Yeah, they're really... I swear I can hear an echo. I think it's because the screens are very close to me now. Sorry. Alita gave me food just before. Alright, let's switch to the overhead. There we go. Nothing too dramatic there. You can see it's different. It looks just a bit cleaner, like I've actually done what a normal person should do and clean their workbench. Cooking some pastries. Gonna be... No, I wasn't cooking pastries. Alita was just making crackers and cheese with various condiments on top. Okay. I feel like also the colour seems to be a bit better overall. So with the new panel and just better lighting in general. And there's a slight one, but it's not a problem there. It'll probably dampen as I improve or stick more things into the workshop. Okay, let's see. I just realised I have not plugged in the microscope, so we're going to have to manually switch this over. Alrighty. Okay, just noticing something. Let's see. I need to get bigger text because I can barely read what you guys are saying. 125%, that does the job nicely. Alright. Okay, so this here is a job that I realized came in a while ago when I did not have any spare chips for this section. And look, we know pretty much what the outcome's going to be, but we still have to try it and prove that it is in fact dead. This being a 1700 board, it's almost inevitable that it has no life. I just hope this isn't the one that I yanked the chip off recently. I'm fairly sure it's not. I can't remember, to be honest. Anyway, we'll clear that up. I've got to get used to everything being in slightly different positions now. I'm going to try my best to actually maintain a reasonably clean bench top. I know, it's deluded of me, I agree. Okay, let's extractor on. At least the nice thing now with the extractor is, of course, that I get a beautiful breeze blowing over my feet. and that's probably perfectly fine for winter, sorry, summer, but I suspect it may haunt me in winter. Okay. Okay, we just lose chat. Yeah, I'm not sure what's going on. I think we have problems with our internet feed. Sounds about as loud as... Well, fair enough. I haven't actually muffled it or anything. I do have the carbon filter coming this week, so that may change things. Most of the noise is probably from the underside. I just realised I've got all my damned tools packed away in a box, so I just have to get my tweezers out. What the flip? I got hot glue on my tweezers. I remember now why I have hot glue on my tweezers. It's because I was fixing up my headphones. And the headphone, there's a little metal grounding insert that clamps onto the headphone wire that goes into the transmitter, and it was not holding the wire anymore, and it was just sliding freely up and down. So I put an end to that by using some hot glue to just basically meld it all together. Sorry, bro. Alright, so they look a bit better now. And at this point I realise I do not know which orientation that chip has. Good thing I've got board view and schematic. I'm not even sure where to put them though. Okay. Actually, this is quite interesting. With the newly arranged monitors, I'm actually blind on the one that's in front of me. The microscope gets in the way. Alright, schematics, there we go. And looks like pin 1's down there. Okay. Jolly good. It's interesting. YouTube is complaining that it's still not receiving enough data. I don't know what. YouTube's not receiving enough data. I'm just going to check my statistics. Well, I don't know what it's complaining about. Looks like it's YouTube being YouTube. Okay, let's go back to microscope. Okay, scratch out. Gavin. What did I say? Pin 1 was what? Down. Oh yeah, down the bottom here. I have a nasty feeling I've actually already tested this and I actually need to be sending this back to the client. For some of that probe mark on the cap Just makes me think of it for some reason. Oh, that's the old EMTech. Oh well. I need a better screen. One thing I have found is often when we lose this chip, there'll be a great big burn mark on the metal die assembly in this one as well, but we'll see how we go initially. Overhead. Man, I hate having to manually change my... manually changing the scenes when I switch the microscope in and out is actually a pain in the ass. Makes me realise how thankful I am for the automatic one that I have, but like I said, I forgot to plug it in, so I'm not going to get up and route that cable this time yet, but it is a pain. Flexel, is that the stuff that's always been pumped around on the like midnight sales channels? Uh-oh, that's not good. No. 20 volts. 20 volts is not the problem with these boards. You can get that. You get that. The trouble is it never really boots. Yeah, it just, yeah, it gets up to 180 and then it gives up. So basically, one of these NANDs is dead, and so there is no hope for this one. I'm genuinely confused though. I really thought I had... I really... Yeah, I don't know what's going on. I packed a lot of machines to send off to these people again. Sadly, I think about the last 9 or 10 machines that they've sent in have all basically been this. And that's quite depressing for me, and I imagine for them. Yeah, having the wood board there really helps a lot with the color balancing, and it's actually more about the exposure, because with the white bench top, it would just simply think it's been overexposed, and it would make everything quite dark up here. Yeah, that's sadly a dead end on that one. So I'm just going to reassemble that machine. I'll have to check, make sure I haven't actually marked that off. It's a good thing the boxes haven't shipped yet, because I am genuinely thinking that I thought I had packed that one. It's going to be kind of embarrassing if I have not. Or rather, the embarrassment factor is going to be me having shipped someone else's damn computer. Let's see. Toothbrush. Hey, 555. Hey, Paul. Okay, let's get some wholesome IPA. And just... I'm not putting this through the ultrasonic cleaner. All I'm going to do is get the flux off. It's not going to be perfect. No idea what that was. Get the flux off, and then yeah, there's no point ultrasonic cleaning this. It's a doomed machine. The only way you can actually fix these machines is to replace every single NAND. And it just is not worth that risk. And most of the time, you don't get these boards with anything but NAND failures in most cases. So trying to find a board that's failed for another reason, that's pretty rare. Yep. Oh, big goop of flux there. Hey, Keith. And of course, are there any Australian or New Zealanders watching? I'd be very surprised at this time of the night. But if there are, remember that the wearer screwdrivers are being drawn tomorrow. Valentine's Day. Okie dokie. I think we're done. Now we've got to put the damn thing back together. The part I don't like. And Nelson. I think the way to try and avoid having your workbench go to hell in terms of clean state is to not be rushed in your jobs, but that is exceptionally difficult to maintain for any period of time. I mean, you start out and you're kind of like, I'm going to keep this all nice and clean. I'm going to, you know, when I've done one job, I'm going to clean back and all that sort of stuff. But then someone comes racing up to the door, quick, 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 you got to save this, you got to save that. And you're like, okay, I'm on my way. And you just drop the job or whatever. And before you know it, all your hopes and dreams of being a clean workshop just die. Actually, I haven't even looked at the countdown timer. But for the people who do enter into this particular competition, you've got a pretty good chance of winning, in all honesty. Because there's not that many Australians, it seems. Alright. Let's see. I seem to be missing two particular shroud things. Oh, what are you? Oh yeah, you're doomed. You're doomed. Ugh. This is the workshop of doom. Oh. Hello, shrouds. They're attached on the 1700. My bad. And you said koalas have been placed on the endangered species list. That's interesting. I'm kind of curious if there was some sort of specific breed of koala, or, you know, something like that. Half the trouble with koalas is the damn things won't stop just having sex all the time, and so they get chlamydia, and they share that amongst each other. So they're just a bunch of rampant... For something that sleeps so much, I guess that's the thing, they go at it all hammer and tongs during the night, and then they're worn out the next day, so they sleep. Let's see. Maybe that's what happens. Okay, what are you? TX6. I'm not going to use a TX6 on this one. Where's my TX5? This is the downside also of just throwing everything into a box. You sort of tend not to know where everything goes. I mean, you think that everything's gone on in the box, but then you find out that that is not the case. So we've got T4, we've got T8, I need T5, and I found T5. Marvellous. Koalas on the list for Queensland, New South Wales, and ACT. Okay. Certainly the fires, particularly from like 2019, have been exceptionally destructive towards their habitat. Yeah, I'd say obviously there was a great number that were lost directly from the fire, but then there would have been a huge number that would have died of starvation ultimately. Yeah, those trees don't grow back that quick, and koalas are somewhat specific about which gum leaves they will eat. You can't just put them on any old gum tree. And so there you go, koala. You got gum leaves you can eat. They have quite specific tastes. Being a 1700, we have to engage in this ludicrous process of taping down multiple flexes in order for us to have a chance, at least, of reinstalling the board. Okay, the 2 should do it. That one should stay. Actually, no, I'll do this one over here as well. You can be a little bit tricky. Without putting that sort of bit of tape protection down, the 1700 can be a real... basically it's a board of nightmares trying to get it back in. As if it isn't bad enough that they just die all the time. Then you have the indignity of not even being able to put the corpse back in. Ach, niemand. Come here. Everybody forgets about the Wi-Fi. Alright. I stayed up pretty late this morning, so maybe I was trying to be a koala too. But I think it was about 4:30 I stayed up till, and I'm blaming Graham of Atmel IT, because he was doing a old Athlon XP 1800 motherboard recapping process, and it was entertaining to just watch him. And he had his friend there, friend of Graham, I forget what your handle was. I don't know why I'm bothering with this. I guess I've got to do it. Present it back. Maybe that's what morticians feel like. They're like, it's dead. Why do I have to make this all pretty? Just put it in the box and let's go. Oh, this is not Captain Tape. It looks like Captain Tape, and they sell it as Captain Tape, but it is not Captain Tape. It's certainly not anywhere near as expensive as Captain Tate either. That's your biggest clue that it's not Captain Tate or polyamide tape if you want to go for the actual generic term, well, the technical term. This is really just yellow, transparent, clear tape. Yeah, Paul, I saw you ducked out a little early for health reasons. And I was just passing out from staying up too late. Especially considering that I was doing all of the Fume hood stuff last night, part 3 as it were. Or was it? No. I did part 3 during the day today, I think. That's sad, I can't even remember what I was doing. I did have a 800, not 800, a 8-inch carbon canister on order, and then the supplier messages me and says, we made a mistake. We actually don't have 8 inches in stock. We've only got 6-inch ones in stock. Will that be okay? And fortunately, I am able to take a 6-inch one because I have the reducer 8 to 6. It does mean I'm not going to get as much airflow because the back pressure will be a little bit higher, but it'll still be okay. And I also, you can't quite, let me see if I can reach. Come on, reach. Okay. This here, I'm going to try and drop it probably 30 millimeter. It's protruding up way too much, and I just got to drop it down. I had to take a notch out of it here, which is not a big problem because it was becoming a pain to swing the microscope. Like every time I try to bring it around, just that last corner, it would strike it. And it just ticked me off. So I thought, fine, that's it. Yeah, cut that out, which isn't a problem. Right, we want TX5, and we're also going to go back to Zoom. There we go. RZ. It did part 2 with the HEPA filter woodwork, right. Yeah, part 3 I recorded, and I'll edit. There was a fair bit of chopping and changing, as you can expect. That's the other thing you got to remember is, this is all prototype stuff. And with prototypes, you're going to have an idea of what you're trying to do, and then there is what you end up doing. So when people are like, why are you wasting your time? Yeah, it's taking you forever. And so, well, it's part of the prototyping process. These things do take time. Excuse me. Oh, wow, piece of tooth. Yep, that's fantastic. That's just what I want to see. And like, chances are, I'm going to make another revision of that to make it better. Some things you just don't see through until you've actually constructed a prototype and you go, oh yeah, you know what, I can do that much better doing it a different way. It's a big black hole loose. Oh, it's okay. That, it just falls straight to the floor. I should put some magnetic mats on the floor and that will capture everything. I also had to move this whole workbench forward about another 30-40 millimeters because I found that where the bench was before, this encroached to about here, and it was just a little bit too close for me. Okay, we've got, oops. Windows screen will block screws. What? Air System Revision C. Yeah, it might go up as high as AC. Do enough revisions to loop around, so we have A as the leading prefix. Okay, I feel like I'm missing a screw there. A Flying Scar from Belgium. Sorry, what? Yes, we run Linux here. Even Louis Rossmann runs Linux now. I'm actually very surprised. I mean, I know he's more than capable of doing it. I know he has for many years run Linux. But honestly, I thought he'd pretty much thrown Linux out the window and was sticking with Windows now. And I wouldn't blame him one bit. I would have personally... Yeah, the only reason why I use Linux most of the time is because I do love the command line interface. And it allows me to interface with a lot of my electronics that I build. I know Windows does a pretty good job these days, but after a while you've invested enough of your life into something that you just keep going with it. Did you move the microscope forward or did you leave it? Ah, yeah, I did move it forward. You can see the old holes there. So they're the original holes along with this one, and then I spun it around. I just needed, like I said, I was running out of clearance for that, which is funny because a big part of the reason why I went to the lower mount filter is because the head of the microscope would crash in to the snout, and so I thought, right, that's it, I'm gonna make this a what do you call it, a lower mount, and then the microscope won't crash into it. Well, that's what the universe does when you try to do things for one reason. What is the benefit of running Linux? Is it better for programming? Look, really, I think I wouldn't say that definitively, no. I think Windows and macOS provide somewhat more, how could you say, assistive environments for programming. Things like Visual Studio and whatever they use on Mac for Xcode or whatever they have nowadays. Carbon, I think it is now. But no, I think in terms of support environments, integrated development environments, Linux is actually pretty terrible. I know there's Eclipse. I do know about Eclipse. But the thing for me is that I don't use any of that. I just use plain text editor. I use Vim. And that's it. Vim and then the command line to compile. PowerShell on Windows. I have used that, but it's awfully slow. Or at least it was. Probably didn't help that I was running on a terribly slow machine. I suppose that goes hand in hand. But it is nice to see Microsoft actually making considerable moves towards integrating Linux, or working with Linux. Considering that Steve Ballmer basically tried his very best to destroy Linux. I think the engineers won in the end. Visual, oh yeah, that's right, yes, I actually have downloaded it and had a look and play. Thanks for reminding me of that. Maybe it's because I've just never bought an extreme top-of-the-line computer system, and therefore heavy integrated development environments such as Eclipse or Visual Studio, they tend to run like you're trying to run through molasses. It's quite painful. And as such, I just sort of went, you know what, I like my text editor and I like my command line. It works, it's fast. I'm comfortable with it. And I don't really miss out on too much. Microsoft is a bit of a different beast now compared to what it was in the late 90s or mid 90s to early 2000s. I do feel they have changed quite a bit. But I don't think it's because Linux or open source won the war, as it were. I feel like it's more a case of the market, the rest of the market, Microsoft's actual competitors, took a lot of Microsoft's market away. Particularly Apple. And so Microsoft's like, well, what else can we do that's unique? I don't know. I just don't feel like it was because of Linux that Microsoft has changed to be a better, a better citizen, as it were. I just realised I didn't need to put that down yet. I've got to still do the Wi-Fi connections. Vim just works. It certainly does. And it's exceptionally lightweight, but it's exceptionally functional for that lightweight. You can go the other end of the spectrum and you can use Emacs, which probably runs Visual Studio as a macro. Seriously, Emacs is just one of those programs where the features just don't stop. Oh, squeaky. Someone needs some grease. I had to wipe all the grease off because all that sawdust that was suspended in the air, at least for a little while, any of it that landed on the shafts for the microscope, they obviously stuck to the grease that I have on there. And so when I started trying to move the microscope around, it was like quite nasty indeed. Alright, we are not going to connect that little flex because this is a dead machine. We're going to put a little piece of tape over it. And stop anyone having hopes and dreams of reviving it. I have to go to face cam now, sorry. Oh, back in the SCO Unix days, that was horrible, yeah. I just realised it didn't, yep, sorry. We're getting into the habit of expecting the microscope to switch back automatically. Yeah, SCO Unix, the whole SCO versus IBM thing, that was a huge waste of time and money. Lawyers got very rich, that's for sure. SCO was a nice company. They had some good products. And SCO Unix was actually, I had a license at one point that was in the sort of like mid-90s, but then it all went to hell. Different people came in and tried to do the whole litigation thing. That didn't go so well for them. Oh, what's this? Someone lost a pet. Oh, so I'm very sorry to hear that. That's, yeah. No, I can understand that yeah, you jump online here and at least some sort of sense of knowing who's around. That's going to be heartbreaking. I do not look forward to those days. Oh, for goodness sake, that sticker won't come off. Okay, another empty container. I suppose I really should have checked pardon me. Ah, damn it. No. Can't see you guys. I can't have you seeing me type in my password. Oh, what was that? 1179, wasn't it? Yeah, I have actually marked that as a no fix already. Damn it. Kind of wasted my time there. Oh well, it's committed. I'm actually going to note here, confirmed. Confirmed dead. Now I'm going to go into the other room. I have a horrible feeling that I've got 1179 marked on a box that shouldn't be. Hello, box of tricks. Okay. Let's see. 1106 dead controller. 1108. 1045. 1076. Wait, didn't I have a 1076 just then? Oh no, 1106. 1173. Oh crap. Yeah, okay. My bad. This is yet another dead machine. So this is 7 machines I've got to send back to these people, all dead. So sad. And a lot of shipping. Alright. Well, something a little bit different. I am not actually going to be repairing something now. I am going to instead see if I can build something. And this is a replacement controller for my Reflow oven. It's probably not going to work because I designed it. Okay, we've got resistors, fancy stuff. It looks like I've been putting stuff together but not actually soldering it in yet. Probably because I don't know what I'm doing. Oh wow, it even came with schematics and board view. Awesome. Oh man. Too bad it's the printed type. Schematics and board view. Fancy that. We've got fuses. And what? 4-pin diode bridge? Okay, that's not right. Doesn't matter. Cute little boxes for something that doesn't need a box that big. Still, that's not up to Hewlett-Packard levels of insanity. What's that? Is the overhead cam on autofocus? I suspect it is, yes. So what are these? 39 ohms. We need one of those. 300 ohms. Oh, that's interesting. These are 330s, aren't they? Yep. Some designs with this particular triac drive system, they use a 300 and a 330. Others use both 330. It's not super critical, but it's... I'm gonna sneeze. Well, I think my head blew up. But before we can do any of this stuff, we actually have to do that stuff. These are actually element 14, Final. Now I'm really hoping that this thing still works. I didn't know how expensive they had become. This is a self-contained AC to DC converter, as in it'll take 240 volts and then it'll convert it out to, let's see, 5 volts DC. So it takes place of transformer, bridge rectifier, capacitor, regulator, all that stuff. It just eliminates all that, and instead you just put this little brick in and you're done. Very easy, very convenient, a lot less trouble. Newark, yes. Okay, so this is the page we need, and this is going to be using a Mega 8, which means I'll use a Mega 88. It's even got a crystal. Alright. Yes, it's a switching transformer. Let's see, half the parts I want are going to be in here too, I think. Hey, what are you? You might be an 88 I can steal. It's switching, yeah. There's no way it'll be a capacitive dropper, not for the current it can supply. Alright, let's get into it. I will fix the focus, just give me a moment. I suppose I should check what chip I've got here. Mega 48, that's going to be more than ample. I know it's going to be more than ample because I wrote the code and I know that it's about a 2K piece of code. Mother! Drop my flux on the floor. It's going to have a few interesting tidbits on it. I don't think I'll rip that one off that other board. I've got plenty of these chips. I should just grab it. Let's see. Microcontrollers. Microcontrollers. As opposed to Micro the cat. tiny 48. No, we need the analog digital Mega 16. Way too much. That does not look like a tiny 10. Those do. Wait, seriously? Where are my megas? Yeah. Oh, they're probably in the big box that I put up here first. Which cat was the WoW cat yesterday? Not sure. What do you mean by WoW? So what are you? You're 168s, aren't you? That's a massive overkill. 168, 168, 168. Damn it! Why have I got all these 168s? What about these ones? Need to get a bit more height there. Tiny 48. Oh, come on. Surely I've got a mega 48 or 88. No, they're tiny 48s. I know I must have them around because that's weird. That's struck out. That's not right. Another 168. I may be cursed to have to use a 168. Oh, how very sad. I really don't like using chips that are substantially more over-spec than what I need. It just feels wrong. But it doesn't look like I've got a hell of a lot of choice in this case. I suppose I could steal it from that, or... oh. Have you got one on you? Yeah. Okay, this old board has got a... perfect. That's what we want. And I just broke that connector. Looks like it's seized in there from the flux. It said wow instead of meow. Really? Oh man, I'm gonna have to heat that up to get that out. That's lodged itself in there. As a bit of a laugh, I've got all these old pin through ones. I don't know what to do with. Oh, okay, that's the 741. That's different. Tiny 13, Tiny 44, that's a car-based one. We don't see that around much anymore. 2313, 2313. They will just sit there very much until the day I die. And longer. If you had to home make PCBs, would you CNC or I'd toner transfer? I'm pretty good at doing the toner transfer, so yeah, that's the route I would take. I actually did quite a few videos back in early 2000s and all that, showing people how to do toner transfer. That's a little 8x2 chip-on glass LCD panels. They're very handy little things, these. But what we really are interested in is this chip. Would there be any use? For some people there might be some, people who use, what do you call it, breadboard, or that perf board. It is breadboard actually, the white ones, plastic white stuff. But for me, that's a big fat negative. NOO. Interestingly enough, when I was doing this before, yeah, the manufacturing, we also had a chip shortage. It was quite hard to get a hold of a lot of the Atmel gear, the Atmel AVRs, because they were such a revelation compared to the picks of the time that everybody ran out to grab them. And it was a bit of a risky thing to, when you prepare your project and you're kind of thinking, gee, am I going to get stock for, am I going to get parts for this? Ah, man. I'm trying to watch 6 different things at once there. But in the end, it was interesting to see that Microchip ended up buying Atmel. The big fear at the time when they originally were looking at doing the takeover of Atmel, a lot of us were quite worried that Microchip would intentionally just buy Atmel to kill the product line, but it was a great relief to see they did not do that. Yeah, it's pretty shonky. Looks like it needs flux. Newsagate, that is quite possible. They may well have done that. Because, yeah, certainly the key thing that made the Atmels so nice was that they were dead easy to code. Anybody could make a program with a parallel port and 1 or 2 resistors. They had Linux support, so yeah, it was basically support for all operating systems effectively. So yeah, and of course the Harvard architecture, while initially it seems frustrating, is actually quite good to have. Now, I don't know why I'm bothering with a crystal on this. Now, I don't think I'm going to bother with a crystal on this one. It's kind of an overkill for what I'm doing. Okay, now at this point I really am not sure. Okay, these will be decouplers. These will probably be 0. That's actually going off to a programmable, a serial port, so we're not going to worry about that. That there I'm fairly sure is a temperature sensor, so I'm not going to worry about that. This here is the programming stuff and the LCD interface. Okay, so 10K. Great. I didn't list down what the big fat cap is. Damn it. No, B-Blood, they have their own built-in RC oscillator. Obviously it's not brilliantly accurate or anything, but it's perfectly good for what we're going to be doing with it. I was trying to think what I'm doing here. So I go 10K, 100, 100, 330. Okay, so 10K, 100, 100, 330, 100 nanofarad, 330. Right. I had a huge fight with it. Well, okay, I shouldn't say that. I had quite a bit of argy-bargy with Atmel, and in fact a lot of pro-Atmel people when I was doing this sort of work, because initially there was a couple of early batches of the AT Tiny 13, and I used that as a servo controller, or, to do with servos anyway, and it worked perfectly fine. So I put it all into production, only to find that I had this jitter that I could not program out. I couldn't average it out. It was across the spectrum. It was everywhere. And in the end, it turns out that they changed the RC clock circuitry in the chip, and they've reduced it by about a factor of 10, so it was 10% of the original size. But as a consequence of that, it induced a horrible jitter into the clock. So it wasn't so much that it was not accurate over time, but rather it was because it would just spontaneously jump around, and it was probably related to clock activity or other parts, whatever. But that was quite a fight, because everybody kept wanting to hear that I was saying that the clock wasn't accurate, and it was like, no, I'm not saying it's not accurate, I'm saying it's jittery, and I said, you can't get that jitter out. Because then people say, why don't you just average it over a period of time? And it's like, no, you can't do that, because the jitter is such that it traverses across all scales. Anyway, it took about a month of back and forth, and I put that on the LED spot, and eventually Atmel came back and said, oh yeah, we changed the process, and as a consequence, the die area for that clock is now 1/10 the size it originally was. And I was like, thank you. At least you validated what I was observing. That was, more than anything, that's what I wanted to hear, that I was actually right about what was going on. Showing my age? Oh, come on. I don't know what the Atmels were like in the 1990s. I only got started with them in about 2003, 2004. But with servos, you notice the jitter because it causes them to shudder or shift slightly when they should be sitting still. Because with servos, you send a positional frame every 20 milliseconds or so. It can be anything between 10 and 30 milliseconds or whatever. But yeah, so it shouldn't change from that. And it doesn't matter if your frame size wiggles slightly, at least on most modern servos it won't. But if the actual pulse width changes, then your servo will jump around. And that's what was happening. I'd have these servos that are supposed to be just sitting still, and every now and then they'd go, and you're like, what? What happened there? And you go looking for some sort of interrupt or whatever, messing with your code, but nope, it's not. It was the jitter in the clock. Okay, I need some parts that I do not have right with me here, so go to the electronics box. Hey Toastech. And in the great electronics box we request LEDs and some resistors. Let's call it 1K or so, that should do. Alright, that'll do for the moment. We'll come back to the box in a bit. 1K resistor, because we've got to have an indicator, even though the board will sit inside a case that no one will ever see. It's actually going to be difficult for me to install this, in the sense that my existing controller has run flawlessly for the last 15 odd years. And it's just not a good idea to generally change things that have run flawlessly for the last 15 years. Yet I'm doing it. I guess the key for me is to not dispose of it. Okay, all my LEDs here, damn it, they're all 805s and things like that. Oh, actually, you look 6.3-ish. What are you? Red, 20 millicandela. Stuart, in the 90s I did, but by the time the 2000s came around, it was all Farnell, Element 14, and there was another store that I used a lot, Solex, not Sol, they're sort of like the parent company of J-Car, or the commercial company of J-Car or something. I just realised I don't know what direction I'm going there. No, this is wrong. That's the wrong way around. We're going the ground over here. I'll put in this backwards. Good old ground planes sucking up all the thermal capacity out of that poor little soldering tip. And some moron did not move the part name away from the pad. I don't know how the hell that happened. Electus distribution. Electus, okay, there was another, Electus was part of the group, but there was another one. Solus or something like that. I don't think it was Solex, because that was another local company. Anyway, so I bought a fair bit of stuff from them, but their range was a little bit too limited after a while, and so that's when I started getting more and more stuff from Farnell. Damn it, can't get that hair off. There we go. The nice thing, at least, with when Mr. Smith, or rather Woolworths, abandoned everything was that they flushed out their stock at some stupidly good prices. So a lot of us bought up crazy amounts of old stock, even if we weren't sure if we're ever going to use it. Yeah, I don't know what the deal is with JCar. I'm never quite sure who decides on what they're going to buy or stock. It's a real... It seems like whatever they find when they go overseas for their year, you know, their fun trip to China. I'm very disappointed in myself with this board. Like that C5, that's supposed to be the same text size as C1. Yeah, and as you can see, so that's an oversight. So is this one over here, C3. Dodgy work. Anyway, they're both meant to be 100 nanofarads. I actually don't know what voltage level they're supposed to be, but they can't be anything much more than 5 volts. Because that's the voltage I'm running this chip at. The new lighting is actually helping me with being able to see the parts to pull them out of the little socket, the little containers. So I'm quite happy with this new light setup. Did you use KiCad? I used Eagle, and I still have my license of Eagle, and I have not migrated to the one where where they basically duped us into upgrading to AutoCAD. What's the company called? Autodesk. Yeah. Didn't fall for that one. All right. That's what. Okay, so the PT100 1000 sensor goes in here. I need a button. God damn it, I can't do it. I guess I'll use this GP port here. But the GP port goes nowhere, damn it. Oh wait. Where does it go? Oh, it goes over here. Whew, thank goodness. I was a little worried there. I thought, I've got no route back to a GP pin, but I do. It's these two here. So yeah, the PT1000 sensor plugs into here, and then I use this for a push button. Yeah, B-blood, that's how you know you got good tips. When it makes you bleed. Hey Arnold G. It's a bit excessive, but I'm going to put 100 nanofarads on the push button and the PT1000. The PT1000 doesn't really need it. It's a fairly stable source, but I'll do it anyway. Just trying to think what resistor I need for that. Let's see. PT1000 needs a 10k pull-up. It's actually not a pull-up. It's a divider. It's the other half of the divider. The PT1000 sits on the between ground and the dividing point, and the 10K is between VCC. And so what happens is we pick up the dividing voltage between the 10K and whatever this PT1000's reading, and from that we know what the temperature of the oven is. Now I know most people use thermocouples, but I actually don't like thermocouples. They're slow, they're annoying, you need brains to actually configure the op amps to read them, you need a reference, all that sort of stuff. Whereas with the PT1000, it's a resistor. It's as simple as that. And it's a platinum resistor, so it does cost you about at least $12, $15 to get one. But they're an absolute delight to use. The only trouble is that you do have to algorithmically work out things properly. It is not a linear relationship. Well, not directly, it's polynomial. But it's entirely doable by something like a mega. Okay, so that is pretty much everything we need, because the rest of it's all topside stuff. So I guess we'll do the AC side now. Spookswood, I asked the same question not too long ago, so you're not alone in that respect. Basically it just means people losing their head. And yeah, it's just people going crazy, going, it's got me beat, buddy. I don't truly know why it became a thing, but it did. And we're going to put our resistors in first. That's when you're learning to build electronics, you learn to put your resistors in first, and then your taller components, and then your taller ones above that. Yeah, the whole thing was just a bit strange for me. I sort of get it now. But it was still weird. Okay, overhead. I'm going to be so glad to actually reconnect that microscope sensor. Alright. Professional. Oh, these ones are actually... Yeah, okay, I'm gonna have to... And remember, ladies and gentlemen, you gotta install them so you can read them right to left, left to right, and top to bottom. If you don't do that, you will get smacked. Push them all the way to the board. Fold the legs. Man, I hate doing pin through. Pin through sucks. People who love pin through, or rather I should say people who hate surface mount and prefer pin through, I think they're just being stubborn. Because you can get large surface mount parts, so it isn't all teeny tiny stuff. You can get perfectly large stuff. I mean, geez, 1206 resistors. They're monstrous. Six ring resistors, what is that, 0.1% tolerance on those? And then of course it's fun when you get ones that you can't work out which direction they're actually going because there's some obscure value and they've got gold at the start or something. And then you got to bring out the multimeter and check. Yeah, I mean, okay, it's sort of like, yay, we're doing it the old style, but yeah, I'm not a nostalgic person, so... Noink. I think oh man, ground plane, actually it's not a ground plane, it's just part of the AC circuit, so it's a little thicker and whatever. We'll bring out the more classic tip, the chisel tip. Hey, Alan, I'm making a replacement controller for my reflow oven. Although these days I don't have a reflow oven anymore, at least not in the form of a reflow oven. I have a MacBook board drying oven. Oh, by the way, you can see that the Fume extractor is doing a spectacularly good job. And I haven't even done the efficiency housing top yet, so it's only going to get better. And that's at minimum speed? Yeah, that's at maximum speed. That's at minimum speed. It's not a ground plane tissue. Oh, yeah. Quite right. About the only thing that's not too bad when it comes to pin through parts is that most of the time you don't need to add flux when you're soldering them. Because most of the time, I don't know, it just works out. Whereas surface mount, it seems like you forever have to add flux. Okay, so our resistors are on. Let's see. So, 100. So this here, I hope, is the right type of capacitor. This is a snubber. Yeah. I will find out if I have selected incorrect components very quickly. Things will go bang, 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 and then Dave Jones will laugh at me. Mostly because I have no idea what I'm doing. Like, for instance, just looking at the pad diameter for those capacitors, that's pathetically small. That should have been much larger. Even though that is only snubbing, it's actually snubbing for the controller that drives the big triac. So this is a triac as well. This is an opto triac. So you have an LED on one side, and then that makes the little triac in it, trigger, and then that makes the big triac trigger. Man, you don't want to say that in a hurry. Triac, trigger, trigger, triac. Like I said, 240 volt designs, or mains design, 230 volts technically in Australia now, is not my forte. So I basically take from whatever the data sheets tell me. Yeah, silicon baking mat on this. Beautiful. Could actually probably zoom in a bit more since we're... This here is a barista, sorry. I'm never sure if I'm meant to leave them slightly proud or keep them flush. It's going to end up whatever it's going to end up. Basically what the varista does is if you get a spike coming in on your AC side, it will do its best to take that load, and many a time it will explode. If it's a massive, like a lightning strike or something like that. Yeah. How many tricks would trigger... oh gee, I'm not going to say that. It's just... yeah, Miles, that's why I did have one of those fancy sheets, and I found exactly that. It was like, why is this thing expanding on me? And that is backwards. Wait. What is going on here? Yeah. Okay, that's right. Cool. I was having a brain fart moment. Honestly, with pin through, it's just easier to use this stuff. The fluxes are somewhat gnarlier, but... did you go to sleep already? Come on. Thank you. Yeah, the flux is gnarlier, but... and I will naturally not set that square. I will have to put a heatsink on this as well, because it is going to dissipate a moderate amount of heat. But not too... I can basically just put one of those clip-on ones, and it should suffice. Famous last words, I know. Should suffice, will suffice. Not always the same. One thing that does get me though is with the design, they tell you with the tracks to have a certain width based on what current you're passing, and yeah, that's no problem. But it always cracks me up when you see these TO 220 parts and they say like, oh, this can do 100 amps. And you're thinking, there is no way, you would have to get that track very wide and then magically tapering down to handle 100 amps. I know it's instantaneous, but it's still entertaining in thought. We need another one of those. Hopefully I'll have another one of those. Should have... yeah, we do. As I said, I probably should not be building my own mains powered stuff. I dare say I am woefully unqualified for it. I can handle a bit of explosion, but the main thing I hate is I always worry about the, damn it, the risk of electric shock. Because for explosions I've got the fire extinguisher and I've got the smoke alarms and things like that. But for electric shock, well, yeah, I'm going to be up in a bit of strife there. I really hope this still works. Because like I said, I don't know if I can find another one. Oh, I am loving the fume extractor. And I cannot smell any of the flux at all. It is doing a spectacular job, really is. Even if I say so myself. Okay, time to put some headers in. When I was younger, I always got someone else to plug in the projects the first time. Yeah, it's a good idea. I do need to get a new RCD trip switch. I mean, the house has them, but of course, yeah, that's for the whole circuit. It's not really going to... I wouldn't like to trust it for... Why have I got two batteries here? What the heck have I been shoving stock over it? What the flippin' heck? Been having real dramas with... I do my stock takes on a Sunday night, like tonight, and then I make my order to fill up for my... mostly for my phone repairs. And lately I have been getting some really stupid orders coming through, and I'm like, what is wrong with me? I was like, another person does the order, or what? Okay, that looks like it's 6/20/20. Maybe these are just dead stock items. 6S. No, that is actually a brand new item. And lo and behold, it's a 6S. Like, I don't already have a dozen of those. On the weekend, a person came in and they wanted their iPhone 6 battery replaced, and I was like, yeah, sure, I've got them. And I had one, and it was a dud. These ones are being duds, and 2020, that's too old now. That basically just goes straight into recycling. That's too old. Yeah, I don't know what I'm doing with anything around here. Completely incompetent. Let's see. I need upright headers. Yeah, okay. Bound to have... They should be in here. No. Oh, come on now. Do not tell me I have run out of the most rudimentary... Ah, here we go. These are ugly ones. I don't know if it shows up in camera, but these have like a nickel plate on them, and they are very annoying to solder, whereas these ones have a gold plate on them, much easier to solder. But it would appear I have only nickel plate. Looks like nickel's back. Can't believe that. Looks like I'll be ordering a few next week. Yeah, these are all right angle ones. Double right angle. I cannot see any... No. Well, we're going to have to go for the nickel ones, and they're going to suck. B-blood, no, because what's going to happen is that a few weeks later or a few months later, the customer is going to notice that the battery doesn't work very well, and they're just going to come straight back here and want me to replace it under warranty, of course, and I would. So it's better for me to lose the $13 or whatever it was. Right, I should have done them before I did the... well, this is going to be fun. This is where you try not to burn your finger too much. This is where you need 6 hands. Okay. The trick is you tack one of them. Come on, heat up. There we go. Tack one. Get the vertical alignment right. And burning, yep. And then you just run off all the others. Let's make sure it's sitting firmly. I'm just redoing the first and the last one again. Particularly the first one because, you know, I moved it around, which means it probably suffered a little bit of dry joint. You don't actually have to have the solder directly on the part, but it just makes it easier if it's closer. Okay. That was a pretty awful tack. No, funnily enough, it ended up identical pretty much to the other one. Alright, good to go. Helping hands. Oh god, no, I hate helping hands. Sorry, I don't mean to sound nasty or anything, but yeah, helping hands. I bought a few different variations of those things and I do not at all find them very helpful. Most of the problem is the clips that they use. Okay, both the push button and the PT1000 sensor are not polarized, so it doesn't matter. I don't have to have some sort of polarized connector here. Blue tack is, yeah, it's certainly sooner do blue tack. Amazingly, that actually went in straight. I didn't get to see how Adamant's Graham's what do you call it, recapping went in the final result. He was brave to go ahead and use that desoldering gun though. I mean, the amount of heat that motherboards will gobble up, I don't think many soldering guns cope with that. A Gibbo, change out the chief alligator and use Miller clips. Oh, okay. Right, we're fundamentally done. No, we are done. I just have to program it, and that should be it. Now I can hook up 240 volts and we can see how it goes, and I've just realized that, yeah, I don't know which side. I guess this should be the input side because it's got the varistor right there. And if you're wondering about fusing, I am using a panel mounted fuse on this particular job. So it is fused, but it's at the panel, which I consider to be somewhat safer than having it on the board in this particular instance. Because at least if something goes wrong, the fuse blows or whatever, you know, it's off on the other side of the board. It's not on my ill-conceived contraption. We do still have the exhaust fan running, the extractor, because I'm trying not to breathe too much IPA in my life. Trying. Turn down the volume. How's that? Oh, you mean for actually when I test it? Haha. Right, I'm a little slow tonight, folks. Wait, that's pretty much every night, isn't it? Okay, get rid of that. Like I said, the flux from this, it doesn't... It leaves behind that sort of classic gnarly flux, crusty residue that you see around most pin-through legs. I mean, Multicore is a good brand, yeah, I've got no problem with that. It's just still a bit of pain. Okay. Now the first thing I've got to do is program this. Now there may be some dramas because I don't recall what the microcontroller model was of the previous one, but we'll find out pretty quickly. Just throwing trash over there. We can turn off this. Put those last little headers in there. You watch, I'm going to forget to order more headers. And in the next project I'll be like, oh, I've barely got any headers left, I better order more headers. And so on and so forth. Till one day I actually need headers and I will have no headers. And I will lose my head. Boy. What is the brand of the Fume extractor? It's a PL Daniels Fume extractor. Very exotic Fume extractor, and a very good one at that, it seems. Let's see, programmer, Atmel programmer. So AVR tools. Just go out a little wider. There we go. Thank you, Miles. I will try and remember. The lack of microcontrollers is actually also playing on my mind. I'm not sure why I didn't have more of them. Last time I checked I had many choices. So I'm not sure. I think I must have another box around the house somewhere that has all of those things. Okay. Right, I need a USB, mini USB cable to do the next magic step. Where are you? Little mini USB. You're my favorite, so you should be here. I mock all the other USB connectors, but you I praise. Ah, no, that's your evil, ugly brother. the micro USB. Ah, I see one. It's a little bit short though. Alright. Okay, I'm gonna be back in a second. I've gotta go have a break for 30 seconds. Back. Alright. Yeah, those are all gloves now. That's that would be funny, Jonathan. Alright. As soon as I undo these, I will find where the other ones went. It is the way of the technician. Okay, hopefully I have a port that I can utilize here. Fairly sure I do. Oh man, I got USB-C, not USB-C, USB 3. Oh, guess what I found resting up on top of Old Smoky. Yeah. A cable attached, all ready to go. Plugged in as well. Jeez, I knew I'd find it. Okay, time to put the gloves on. Now that they've had a chance to air out. $6120 or $62,180? You're talking about the SSD controller ones? VREG? Okay. Okay, it's detected, so that's a good sign. But now I've got to do the hard part, which is actually the programming side. Schematics. I don't know what the difference between M-locate and P-locate is. It's not going to be able to help me anyway. I think P-locate would probably be package locate. Anyway, that's not helping me right now, so what I'll do is a slightly different technique. Weird. Please do not tell me that I have lost my... Come on, come on, come on, you gotta be in here. I know, look for the one that's... Board dryer, there we go, no wonder I didn't find it. Okay. What about... Oh, lo behold, it actually is going to be using a Mega 48, so we'll be able to program this directly. That's fantastic. Assuming I get the polarity right. And it looks kinda... Yeah, it looks kinda groundy there. For a moment then that felt like that that LED was burning away. So time to program. Ach, niemand, come on. Guess who has installed the AVR tools? Apt install. AVR dude. AVR libc. Thank goodness I got a fast internet connection here. And it's already done that. Programming. Done. Alright. We need a LCD panel. Let's see if I can get one in the other room. I'm fairly sure I've got a bunch of them that are just rotting. Fantastic. This is a classic 16.2. In theory, these should all just line up, and I'm probably going to be one short because this is a non-backlight one. The trouble is I don't know what the... Ooh, okay, we have to go there. I might plug this in to the... by plugging this back in, it gives it some power, and we should get something on the display. Once again, we use the word should rather abusively, I think. Okay, so we do have it our... what's going on there? It's like it's not being driven. Okay, let's try a different project. Okay, the reason why I'm trying a different project here is because I know that this design was derived off a different board. It wasn't derived off the original one that... Okay. So there might be different pins going on here. No. Or it might just be a case of it's holding it high, and so the... Yeah, actually it might actually be that. Because this is connected, the AVR is not actually resetting. It's stuck in a... sorry, it's not running, it's stuck in a reset state. Okay. So, there's a couple of things we can try. We can... just put 5 volts to it, just to see that it runs. I think I might do that before I go slapping it with, 230 volts. Did you program the internal clock fuse? It should be done, yes, because it was part of the project. This is going to be bodgy. But bodgy makes entertainment. I really only need to put it on these two. Positive there, ground there. The other possibility is that that chip may have actually already been told that it's expecting a crystal, in which case that's not going to work so well for us. We may have to take it off. There are ways to rescue it. Yeah, you can just go put it on a board that does have a crystal, but we won't be doing that tonight. And I'm going to drop it down to 200 milliamp. That should be just fine. Power off. No, she ain't running. I'm wondering if I've got something offset by 1. That shouldn't be it, because like I said, these two pins down here, they're backlight. Is the contrast wrong? Basically, you get this display when... Oh, what happened there? A dodgy cable, maybe? Something's a bit dodgy with that cable or the display. Let's see if I've got another one. Oh, damn you. No, it's not I2C on these ones. It's a different. It's just the 4-bit mode. Okay, we're actually going to cheat. Wow, that was a nasty noise. We're going to cheat in the way of the fact that we're actually going to take the working unit and pull it apart and try its display, because we know that definitely works in here. The behavior where it gives all the bottom row as solid blocks like that usually is when it's got power, and it's sort of being initialized, but it's not getting any signal, or it's not getting any signal that understands. Oh, wow. Okay, I remember this now. Yeah, so this is about 15 years old. It was quite a project, and these are all handmade circuit boards that I've done. So, you know, we've got the triac switching board, we've got the DC in, you know, this is the 5-volt sort of thing. We've got the main controller board there, and we've got the programmable interface for the AVR programmer. And that there is the, what do you call it, the PT1000 interface. Some dodginess there. And what's interesting, I've actually made my own serial protocol and then a shift-fed display here. Oh man. That's pretty crazy. And the reason why I did that, I think, was I had issues. I didn't have enough pins or something on the other one. Yeah, the 4-bit parallel mode is what I use. Oh no, you mongrel, you're not going to fit! Oh, the torture! Actually, that's kind of interesting. No, that is right, yeah. So yeah, this will be my serial to parallel converter, and I'm using a tiny 2313 to do it. You can just use a shift register with some trickiness. Oh man. The things I enjoyed building. Just checking something here. Alright, so we are starting to pin one there. Alright, well I guess I'll try this again. I'll just redo the solder joints and see what happens. It's a serial version that I've got there, it's not the I2C one. But it wasn't actually a standard serial or anything like that, it was just something I conjured up. Basically just bit pumped it. Yeah, that actually looks pretty good, so I'm gonna guess that the fault is actually in here. It'll probably come loose. It needs just a bit of clamping down, probably. Come on down and get clamped. I can't use the new one. I can't do a swap here because they both have different interfaces on them. This one has a cable-based connection, the other one has a pinhead connection. Hey John, yeah, it's oh shit, it's 2:30. Okay, I was about to mock you for mocking me, but then I realised you're actually in the right this time. Damn you, John. Have I got the orientation right on this though? Well, actually, I can't see any other way, because if you rotate at 180, then you're going to have a mismatch on the pin numbers. So, it's got to be this way. Let's do it like that. No. Cool, blimey, mate. Alright, well, what we'll do is we will just make a socket version. The trouble is, no, we can't plug that in. No, we're going to run into the same issue. If we make a socket version of it, we still have the problem where the transformer is in the way. Goddamn transformers. I'm just going to have a look at the source code and see what it says. But from what I remember, what I derived this from, it really should have just been a plug in and go. So yeah, I'm definitely stumped here. Hey Rob Brown, good to see you, Rob. Let me have a look at my pile of wires. Maybe I've got a strap of rainbow wire that I haven't completely stripped apart like a moron. I know I did do that to some the other day. What was it I was doing something dumb. Okay, now I don't want to make another one of those. Aha.
Uh-huh.
And another one. Alright, this should be good. Come on, you little mongrels. I suppose they don't take too kindly to being referred to as mongrels. For some reason the pin headers on this LCD are actually very peculiar. Right. It's like I've clipped this from another job, and I literally have basically just cut the legs from underneath it. Oh, bravo. Yeah. Okay, I've literally cut the legs from underneath. That's why it's giving me grief. So what we'll do is we'll actually just desolder this one. Now for desoldering these, it's easier to just lift the plastic retainer off first. Yeah, maybe break the screen. And then once that retainer's, the plastic thing's off, they're just, you know, standing on their own, little individual pins. Obviously you don't want to pull the pins out, or else you will ruin the board. Being a little bit more difficult than there we go. Okay. Tweezers. Come on. You'll probably find that there's actually nothing wrong with that other one. It's just all me. Me. I haven't butchered that too badly. That's a terrible job, Paul. Terrible job. Now it's a pity I didn't have right angle socket headers. I do have so, oh yeah, well I can actually do it. I'm gonna do it. I'm gonna do it. And there's nothing you can stop me with. Do it for my ego. My ego wants me to. Okay, what have we got? 6. Shut up, Gecko. Okay. So we're just going to put 6 up here, and then 4 down there, and that will let us attach that. Pin 3 on the LCD is contrast. Nope. Pin. Oh yeah. Sorry, no, you're right. But I do have that. So I've got the contrast here. And the other thing is, it should be showing up. I mean, look. Yeah, you could be right. Let me just. I shouldn't have said nope like that, because that just makes me seem like an idiot. So I've got 10K and 330. Oh, wait a second. Why have I got another 330 there? That. Alright, so this is backlight power, which we don't use. That's ground. Another ground. That's contrast there. Okay. Now I've got to go get another panel. Okay. Alright, so this is another panel. Okay, so the first two, there's no backlight on that. So yeah, ground is the next one. And then yeah, we see we've got 330 to ground, 10K. Wait, what? How did this even work? Man, I'm gonna have to. I don't have my Eagle. I don't have my Eagle program here. Okay. Oh, hilarious. Okay, so this is what we've got. Gibberish, because Paul doesn't do his boards properly. Okay, anode, cathode. What a freaking disaster. And they have no representation in reality. Yeah, it looks like I'm replicating exactly what I've got on that other board. Like this board here. This board here is the same configuration, and I know these worked. Even though you can't see anything. Microscope. Yeah, it's basically the same configuration, so you got your backlight power, your ground, and then these are the other board interface, so your ground, this here, which is looks like 5 volts into that, and then this here is the contrast. So yeah, pin 3 is the contrast on a non-backlight unit, whereas pin 5 is on a backlight unit. Okay, thanks for confusing me. And yeah, that's what I've got. So I've got ground, power, contrast, and contrast is set. So yeah, that's actually correct. Nice shiny connections though. Right, my workshop's becoming quite the mess now. Oh, sweet mercy. Someone... Right, that explains why it was a little tricky to get off. Somebody put hot glue on there. How dare they? I'll have to clean that up. Right, so that's the first 6, and then we've got 4 down here that we're going to do. Now I'll just chomp off 2 of these pads. Hey, triacs. So yeah, that'll be fine. Ach, niemand, don't move it. It's a great way to get nice, nasty cold joints. Wow, these this connector is dreadful quality compared to the one that we used before. Even with my shonky soldering. Okay. Alright, that should be a fit. Yeah, that is a seriously dry joint on the end there, but it shouldn't affect things. What a schlep. And it is correct that that pin is poking out, because that's the backlight side. And we don't do backlight side. Backlights are for people who like bling. Okay. Alright, same issue. Okay, so we definitely got a coding or whatever issue. Ah, boy. At least we've got ourselves a nice little test display now, though. Okay. Hmm. Because I'm fairly sure both lines get used on this. But at least it's not wiggling around. Yeah, it's not changing when I wiggle it anymore. So we have a proper testing situation here now. I've got to work out why it's not working properly. Now, it might be that the fuses are incorrectly set, in fact, but we'll have to see. It could be that I was dumb and programmed it with something that it wanted a crystal with, but probably unlikely, because if that was the case, then we wouldn't have been able to code it, flash it a second time. No, not on these ones. Remember, there's all different models of these LCDs. Okay. And on these ones, it's, wait, what? Damn it, why do people make me question myself? No, there's no backlight on this one. Oh, yeah, that's it. There's no backlight. Oh my god. Yeah, you're right on this one. If it had the circuitry there, it would be. Let me have a look at this one. This is what I get for doing it at 2 a.m., yeah? Is this because I copied the design from the old style that actually did things differently? Crap. So I've actually got them back to front. My fault here is assuming that what I had wired up there would always be correct. That's the same situation here anyway. I've got my 6 pins from 1 and then 2 back from 16. Yeah, because I got... It must have been stemmed from the... I did have a backlight version originally, and I got rid of it. I'm just going to have a look at the values that we got here on the resistors. Okay, so that's a 300 ohm there. Oh no, that's to the backlight. I'm kind of cheating here. I'm actually using a divider. That is such a cheat pull. Got a cough. Yeah, so we got the nibble data on the pins. Was it? Let's see, 14, 13, 12, and 11. And then you got all your rewrite, your backlight, and all your rewrite stuff signaling over here. Ach, nee man. This is baie kak. Alright, I know what other tests we can do. We can be dangerous. We're going to plug this in, but we're going to connect up this. And then at least we will know if we have a working display or not. It is a little bit dangerous. This is exposed, but I will keep away from it. Naturally, my damn cable's so short. Why am I always such a short cable person? And I do not have a extension lead. Right. This might be a case of trust me. Oh no, we should be able to reach it. Okay, I'm actually going to flip the power on there. And yeah, you can see. So I'd say we've got something wrong with our flashing. Okay, let's disconnect it. There's something wrong with the code that I flashed. Maybe it's hasn't got the divider set or something. Like I'm running at 8 megahertz instead of 1 megahertz. And that can be enough to cause these things to get upset. So I'll have a check of that. It could also be that I'm a terrible designer. Alright. Time to bring out the code jockey. You can set the you can set the frequency internally now. Then, oops. Ew, that's even worse. Alright, so we're meant to be running at 1000, or sorry, not 1000, 1 megahertz. Ah. I wonder if I've just got a bad AVR. It's quite possible that's a bad AVR, might have a bad pinout on it. Ugh, I hate this. Oops. Okay, what I'm going to do is actually make it so that it sets the frequency internally here. Let's see, Atmel, AVR, libc, set clock, frequency, because I forget how to do it. Something like clock device. Oh, I don't know. There's a function you can call now. libc Savannah. Library reference. I don't know if I'm looking at the really old stuff. Oh boy. See, fuse support. Anyone out there remember what it was? I suppose I can go through my own code because I'm sure I've probably got some projects that use it. Oops. I'm fairly sure I've got a project around here that does set it. Foot switch maybe. Watchdog. Boo, not that. OBS scene switcher. No. Come on, Paul. Hotwire speed controller. There's a function that just lets you basically set the frequency, and it sets up, it overrides your fuses sort of thing. That you know what? I'm just gonna have to Atmel. Yeah, fuse calculator. I used to have no problem doing this in my head, but it's late and yeah. Internal oscillator. Well, hope this works. Ah, that reminds me of the old CGA days. Yeah, let's try that. It's probably not going to do it. I'm going to say we might well actually have a chip with a blown bits and pieces in it. Better put my glasses on so I can actually see which orientation I've got. Yep, that doesn't help, Paul. Damn it, man. Okay, the red light tells me. Okay, make fuse. Okay. So that should have set the fuses to what I'm expecting, and that should give us the standard 1 megahertz. And we've still got nothing. Okay, maybe I've got a bad join in here somewhere. Just doesn't quite feel like that, but we'll have a look. Squeak. I mean, I do complain about having... I mean, we know it's programming, so you know, it is alive to some degree. I'm just going to compare the way the pins are done to other, like, okay, I've got this here, and I have a feeling that this is going to be completely and utterly not the same. So, we've got alright, so on this particular board, we basically, and those 4 pins there are data. And I've done the same here, they're the data. Okay. As you can see, I pretty much copy all my stuff out. And I mean, all this stuff here, that doesn't really matter because it's the contrast. So really, you've just got these 3 pins that you care about, and yeah, they're connected. So I can only imagine that maybe this Mega is damaged. Yeah, maybe one of the outputs is botched up. Unless that 330, that should be 330 ohms. Unless that's not 330 ohms. But 3300, that should be 330 ohms. Hey Defcom. What are you doing up at this hour? And yep, that's 330 ohms. Wrong serial data speed. No, this is all code that's been used a million times over. That's the trouble. This is not a first hit type board. It's basically it's the code from the old oven. So I don't know what the hell's going on. Very confusing. I might just put a new AVR on there because, like I said, it is possible I've got some damaged pins, yeah, from, because I took this from a dying board. Okay, so we go and find ourselves another mega to steal from another dying board. I do remember now actually that these prototype boards that I have here had a tendency of dying. So it could be that I've killed... well, so much for that. Oh no, I've got FlexGate. Oh well. I wonder if Apple will warrant that one. This one could be a pain because it actually is programmed to be running off a crystal, so I might have to copy that crystal across just so I can flash it. It's actually not really strictly a crystal, it's a nice little 3-pin resonator package. Well, the LED works. We should be happy. A little more punch on this. Grab that resonator while I'm at it. Yeah, pay no attention to the resonator going for a walk. And guess what? There's no way I know which one's which now. Oh wait, yes there is. I just realised this one has got a much brighter finish on the text. I actually find TQFPs to be one of the more frustrating chips to hot air. That actually might be alright, I might leave it as is. Alright, well, we're gonna have to flash that. And hopefully it will communicate with me. Glasses. It's a bit hot still. Okay, so hopefully we can make flash, make fuse. Okay, we just did the fuses, so that's good. Make flash. Oh, make. Cat make file, make program. There we go. Alright, so everything's verified. So we'll see how we go now. Could still very easily be a dodgy program, namely me. And I should actually check the voltage, because I don't know what impact the transformer will actually have. And we've got the same issue. Okay, I'm just going to check the voltage across those, because although I'm only drawing 9 milliamp, but it keeps popping up to 22. It's really, actually looks like it's fighting with something. Let's see. It's jumping in a way that makes me think it's fighting with something. No. Can't be fighting much. It's pretty rock steady. Yeah, okay, now I'm starting to get slightly confused. I wonder if I've left something off. Well, in this case with the C code, it is just C. It's not like I've bastardized it with C++ or what's that horrendous programming macroism? What do they call it? Arduino. Oh yes. Yeah, there's no Arduino crap in this. I'm kind of curious. This should not have a 10k resistor there. It's not going to affect the LCD, but that should not be a 10k resistor. That is... yeah, that's the resistor back from the optically driven triac. That should only be around about 300 ohms. Oh, Christian, yeah, I found the fuse calc and I just used it. That's how I got the values that I used before. But thanks. Yeah, this here should be a 300. But, like I said, it doesn't actually play a part in what we're experiencing right now. It only would have been when it came to driving the oven itself. And we're not even close to doing that yet. Oh no, it's definitely not C sharp. Ach, niemand! Oh wow, that was freakishly lucky. Doesn't normally go that way for me. So I'm wondering... yeah, I've got two caps there for power. Like I said, Power comes in, goes to pin 2, goes to pin 2. Where is it? Wait a second. Alright, okay, then it does come back. Alright. So I was worried that it didn't go anywhere from there. But it does come back and then into all this. Let's see. I'm just checking to see, did I leave out one of the VCC lines? But it doesn't look like it. See, I was worried. So this is where it came in from the serial port connector, and that's just the pull up for the, not the pull up, that's the divider half for the PT1000. And I was worried that maybe I didn't come through under the chip here for the power, and I do, so it's all good. So that 100 nanofarad there is the ADC buffer thingy. That one there is just general decoupling, so that all looks like it's going right. So yeah, I'm rather stumped. I'm not really sure what I've got going on here. And all this stuff shouldn't matter. This stuff here, that's just a TC77. That's a temperature sensor, I2C. Really nice, simple, easy thing. And yeah, there's our 3 control lines for the LCD. So I don't know what's going on here. I'm not sure why I've got these 100 nanofarads there, but they're just general decoupling by the looks of it, so it shouldn't really matter. So that'll be ground, positive, reset, reset. Is that reset line going to the AVR? It looks like it is. That's this one here, alright. So that, what's on the other side of that pin? It goes over to here. Yeah, okay, so it goes into there, so that is reset there. And yeah, it's pin 29, so that's all good. I really got to learn to stop butchering my schematics. It's because I just sort of don't, I just don't care. So there's our data lines. And naturally I did not label my signal lines, but that should be them there. God damn it. Well, we're not even involving the transformer at the moment. I could try one of the new chips, but we seem to have the same behavior going on here. But then again, can't believe these have got jammed in there. That's a little fuel gauge chip that measures the coulombs. That was quite a popular product, this one. Basically just, it was simply a fuel gauge for model aircraft in terms of battery fuel gauge. Yes, the screen is confirmed. I'm going to pop the transformer out. Oh jeez, this is going to be fun. Just to verify that it is not playing a part in this situation. This is going to be quite tricky because I've already had to remove it once before. Screen is known good. We tested it on my existing one. God damn, this one never really was a wicker when using pin through parts, because it just pin through just eats wick. It's just like guzzle, guzzle, guzzle. Oh, thanks for the wick, buddy. Yeah, it's an inch and a half, 2 inches of wick gone. Yeah, the traces all look good. Right, now the disgusting part. Do not make me hot air. Ah, damn it. Get out to hot air. Can't even do this under the microscope. I've got to do it. It's just too big. And I need a vise. Hot air does not work like that. It works by burning fingers instead. Alright, we're just gonna have to blob it. It needs more solder on there, which is kind of hilarious because we just took it off. %, here. I don't know what's in that transformer, but it does not want to yield. Okay, we're going MacBook level now. No. That was fun. Potted bastard. Oh, for goodness sake, Paul, get a grip. The board's obviously retaining quite a bit of that heat, and it doesn't take much to... Yeah, some nice juicy dry joins there now. What a mess. What a mess. This better work, else I'll be ticked. Now I've got nothing. And that makes sense, because we reverse polarized it. What the... And I do not have input protection on these. What a mistake to make. Good thing I set the current limit down. Yeah, we're still the same. Ah, well, thank you for telling me to remove the transformer. Nothing changed. I know it was an elimination process, but I should have known that it wasn't going to be that. No, sleep is for those who solve things, not for those who have not solved things. It's going to be something disastrously simple. It's going to be a design difference in the code. Oh, there's no real irreversibles here. There's just mess ups that people can get to laugh at. Oh cool, GVIM's there. Okay. I can't trust my brain to fix things anymore in my sleep. Used to, but not anymore. Back when I could actually read 10 point and I thought maybe 8 point would be better. All I can imagine is I've got a difference in the code here versus what I've got on the paper. That's the only possibility I've got. Okay, so I'm just going to confirm this now. Crikey. Data pins are the PDO to PD3. Wait, what is this? What? Oh dear God, I know why. I know why it's doing this. Oh. I know why it's doing this. See this, this TX string business and whatnot? That is me talking to, you know how I said I did my own hack job code? Well, that is the hack job code talking to the thing. So that's why this isn't working, because this code is meant for the configuration in the box. So that's why that's not working there. God damn it. Now it all makes sense. But it should have worked with the fridge controller. Now, why the hell does the fridge controller have reflow in it? Yeah, that's why I was trashing it all, because it wasn't even pumping data out to that port. It was, it just wasn't. I could probably modify the code, actually. It'd be easy for me to go back and modify that, but I want to just find something that I know should work. Let's see. LOM. Where's my... Oh, there it is. CLOM 06. No. No, it was just that I was using the serial port. It was a software serial port that I did to talk to the LCD panel on the main original box, and on this one I don't do that. On this one I have a direct interface using the normal LCD control. Damn it! I'm just trying to find something that I know should work. Think. Low ohms meter, internal resistance meter. Oh, come on. I'm not leaving it. I have to get something showing on the screen before I can consider going back to sleep. Let's see, fridge controller, iPhone, internal resistance meter, jitterbug, LCD. MCC1. HA. Damn it. Yeah, exactly. I just want to get a hello world up there. Maybe it's just easier if I just start modifying. So what I really need to do is actually copy that project to another. So basically I need to board dryer to board dryer compact. Okay, that's cool. Now, in some of these projects here, someone's going to have an LCD module that I need. No, that's my height alarm. PLD LN3. I think that's it actually. Ah, 2007. Wow, what a blast from the past. Nope, that's not it. That's what I was looking for. They're in the retired section. Two 2009. Jeez. Wait, no, goddamn, ignore. Oh, I don't know what I'm doing here. This is what I'm after. Oh wow. Whew. Alright, let's plug this in and watch overhead. This is probably... I can only hope that the pins haven't changed. It's probably not going to work. But the red light. Make run. Kind of helps if you do it as the root. Let's see if this works. Negatory. Oh. C USB tiny B10. Well, it's actually flashing it, so that's something. But I strongly suspect it probably won't work. I think the biggest problem here is going to be is that I can almost guarantee that I would have changed the pins around. Yeah, the pins aren't the same. Alright, back to the code. No, can't use that one, it's too different. God damn it. What doesn't help is when must be constant node to put in reassembly. Ugh. So I got it. Alright. I'm gonna give this a whirl. If I can even get my jabby jab in. What? Oh, what's 168? That's weird. It worked with the 168, but it doesn't want to work with this one. Oh, great. Great. 413. No one cares about this. There's special characters that don't matter in this instance. Oh god, and the project's too big. Oh my. Okay, that's fine, that's fine. We're going to do a hello world, and that's pretty much where we're going to be stuck. Okay, and this is the critical part. This is where we set the pins. Okay, so in our case, our data pins were D456 is port DO1 or PDO to PD3, and that is what we have here, so that's good. Now the real problem I've got is that these other pins, I've got PC3 through to PC5, and those look like they're set too, so we're quite lucky in this instance that all of this data here is actually correct for what we're doing. Yeah, I mean, you know, AVRs, they're still a good little chip. They're simpler. And yeah, I mean, they're much. I mean, the STM32. What's the smallest pin count you can get on those things? And this is also legacy sort of stuff for me. Hey Keith. Yeah, that's a good idea actually, Miles. Good idea. We'll do that. Okay. Yeah, I hate this. Okay, it's better. So we're going to make this very simple in the sense that we're actually going to have a while one here, and then I need to check the code because I cannot remember off the top of my head how I did a lot of this. Okay, LCD in it, LCD display on. And there's usually you gotta have it, I was gonna say, yeah, usually you gotta have a time delay there. LCD clear. And LCD put as sorry. Just make sure I haven't actually defined that as a function. I haven't. Oh, good. Oh, did not mean to write that. Oh, well. Whoops. Okay. Why am I not seeing it build? Target. That's why. I don't know why it's, let's see, P2, try that. That's weird. This is very naughty and I don't recommend this, but because I'm too tired, this is what we're going to do. It might work, I don't know. Yeah, looks like that one did the trick. Ah, damn it. Not quite. Not quite. So close. Perseverance will pay off. You know what? I'm just going to shove my... I don't know if I should put my face in here or not. No, we'll do the overhead. Nope, wrong one. Ah, shite. And it's upside down. There we go. Been streaming all day. Yeah, well, determination is determination. I really just can't let this go. This is the sort of thing that I won't be able to sleep otherwise. Anyway, all I've got here is a programming failure, basically. Oh, you're generating ADA out. Duh, of course. Okay. Yay! Okay, let's see if we can flash it. Oh, damn it. Come on, I want to see it. Ah! No, the camera must not have died. Oh, kidding me? No, I'm alive. I'm alive. Okay, now I can go to sleep. Yeah, the overhead cam failed because I accidentally reassigned it. Okay. So overhead should be... Yep. Alright. Yeah, so basically the fault ended up being not really a fault, but a failed assumption here, because I took the code... Because the code for the oven is more complicated than the code for the LCD, I took the code for the oven and adapted it, but I forgot that I drove the LCD in the oven code through the Hackjob serial port system rather than through the usual nibble-based LCD driving system. So anyway, we've got the nibble-based LCD driving system, and so that, thank goodness for that, that's working. Oh my goodness. And I gotta say though, I'm a little bit miffed because I hope I have not damaged my transformer. I really don't feel like paying another 30 bucks for one of these things. They're, like I said, they're stupidly expensive for what they are. They're very handy, but I don't think they sold enough of them, and yeah, it's hard enough getting a hold of them. I could probably modify this, or yeah, I don't know. Anyway, it doesn't matter. Point is, hopefully it's not damaged, because this board is kind of designed around that transformer. There would be ways around it. I would simply have to bring the 5 volts in here separately, like have another board or something like that, if that comes to what it is. So, alright, I am out of here. So, sheesh, that was a long